Good morning to all. Good morning. I'm
Good
audible.
morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Rameshwari madam.
Good morning, sir. Good morning.
Rameshwari madam. Rameshwari madam.
Yes, I can hear you. Good morning, Kunshekar. Good morning to all.
Yeah. Good morning. Good morning. Okay, we'll start at sharply 11 o'clock, madam.
Sure.
Beautiful, madam.
People are joining.
ಒಂದು రెండు ನಿಮಿಷ.
उशीर झाला काय तर
Madam, shall we start? Rameshwari madam.
Yes, we can start. Yes,
Yeah.
Professor, we can start, Professor. I hope that you can all hear me. Can
Good
you hear
morning
me?
to one and all present here. We are now going to start the session. We warmly welcome our honored chief guest, Dr. M. Kameshwari ma'am. The title of the today's session is Application of Fuzzy Logic in Daily Life and Mathematics Behind Machine Learning. Now I invite Dr. T. Gunashekar sir to address the speaker, Dr. M. Kameshwari ma'am.
Good morning to all. Very good morning.
Good morning.
I am audible.
Yes, I can hear.
Yes, sir.
First of all,
Yes, sir.
first of all, I thank to Kameswari madam. Just before initiating, I am facing many trouble. Before that, I discussed to madam. Madam giving for many good and positive ideas. So because of madam motivation only, I initiated this. First I thanks to madam. Then I tell about madam. Thank you so much, madam.
Thank you, Professor Gunashekhar.
Simply
Go
call us
ahead.
sister. Yeah.
Thank you,
I
brother.
am pleased to welcome our resource person of the session, Dr. Kameswari madam. At present, she is working as a head of the department and associate professor of mathematics, School of Advanced Sciences, Kalasling Academy of Research and Education, deemed to be University, Christian Coil, Tamil Nadu, India. She has obtained her degrees from reputed institutions and universities. She has 22 years of academic, research, and administrative experience in various reputed institutions. She published 50 research articles in the reputed international journals like Science Citation Index, Web of Science, Scopus, and UGC CARE journals. Also, she collaborated her research with various countries' professors. Also, she has participated and presented more than 50 research articles in the various national and international conferences. Also, she published more book chapters. She is a technical committee member and a session chair for the various seminar, national and international conferences. Also, she is an editor and reviewer in the various international reputed journals. She is acting as a research person in more than 6 workshops, FDP, and webinar. She is also organized more than 20 programs and actively participated in many workshops, webinar, and guest lectures. She was honored by the institution and various agencies for excellent contribution like 8 Best Paper Award and 5 Best Teacher Award. She was traditional such as a member of Board of Studies Chair, developed e-content, organizing secretary, president of panel member in IUCEE, and curriculum designer, member of doctor committee. She has guided more than 10 research scholars and 30 PG students. She published a YouTube lecture on enhanced studies teaching learning process during COVID-19. We are very grateful to welcome you, madam, on this wonderful session of this online international faculty development program and current trends in applications of mathematics. Thank you, madam. Madam, now I hand over the section to M. Kameswari, madam.
Thank you so much for the wonderful introduction of me. Let us go session. Shall I present the screen?
Yes, madam.
Yes. Is it visible?
No, ma'am.
Sharing is not enabled here. Is it visible?
Madam.
Is it visible now?
Yes, madam. Yes, madam. Yes, madam.
At an outset, I thank the organizer, specifically my brother, Dr. Gunashekhar, HOD of Mathematics, Management of Mathematics, for giving me this wonderful opportunity to meet you all through this virtual international faculty development program in the title Current Trends in the Application of Mathematics. It is essential for every teacher to update every now and then in order to deliver the same updation to the students related to the specific domain and also its application. So I appreciate and congratulate Dr. Gunashekaran for taking good initiative to focus applications of mathematics towards all mathematicians. Let us go to the topic now. I welcome you all to this International Faculty Development Program of today's session titled with Applications of Fuzzy Logic in Daily Life. I am Dr. M. Kameshwari, Head and Associate Professor of Mathematics, School of Advanced Sciences, Kalasingham Academy of Research and Education, Krishnan Koil, Srivillikuttur. You can contact me through these mail IDs. This is official and this is personal mail ID, and my mobile number is 98946711271. After completion of this FDP, you will be understanding the reason for the evolution of fuzzy set, know about the father of fuzzy set, understand the difference between probability theory and fuzzy set theory, understanding the importance of fuzzy linguistic variables, understand transition from fifth set to fuzzy set, know about the efficiency and the operations on fuzzy set, and the property fails in fuzzy understand and understand fuzzy sets are used in intelligent systems because intelligent systems is one which are made to cope up with human intelligence. In every session, I start with this word success because everyone wants to be a successful person. In old days, people are working hard, are recruited, now the scenario gets changed. Those are the smart working or recruited individual. Success regarding hard work may be slow, or smart working may be quick. This is slow and quick are fuzzy related linguistic variables. This quick or fuzzy related linguistic variables, we will be understanding these things in future. And we can combine these two things, hard smart work and smart hard work. Doing hard work in the smart sense will make you somehow speed, and smart hard work will make high speed. So do every one of you undergo the smart hard work. Hard work should be recognized and rewarded with damage at right time. Hard work takes the position of hard work. The hard work will not. That is the topic of fuzzy. Fuzzy indicates the way of decision making human. Science assumes decision is very important. We are making machine to take the same decision as information is found to be incomplete, imprecise. You look into the word information. You have to very clear about this information. What type of information you are handling? If that information constitutes incomplete information, imprecise information, inconsistent information, uncertain information, vague information, then fuzzy occurs. You will be understanding all these things through examples later. Now come to precise reasoning. Reasoning is also very important because we are going to make intelligent system means it has to deal with reasons as human are dealing. Since today's era is the digital era, so everything we are manipulating through computers. We cannot live without mobile computers and all. So it is essential for us to make the computer to think as the human, that is intelligent system. So precise reasoning is very much important in that situation. Apart from imprecise reasoning, we require only precise reasoning. Our aim is to convert imprecise into precise. You will look into the words. The air temperature is 18 degrees Celsius. This is precise because it is concrete. 18 degree is concrete. It is definite. The speed is 100 kilometer. She is 15 years old. These are all some definite information. Reasoning means if it is happening so, then it will happen so. So if 190. Look into all this and say that this is our precise reasoning because of the involvement of the word if and then. Since these data are definite, then we are calling this as the precise reasoning. The word reasoning means if and then is involved here. Precise means the data what we are using are definite data. Now let us move to the imprecise. What are the values that can assign to the word cool? To this word cool, we can assign more than one data. It is not clear. It is some imprecise. The speed is fast. Look into the previous example. The speed is 100 kilometers. It is a definite value. It is not a definite value, but it is a somewhat imprecise and uncertain value. We are having some confusion in assigning values. Hello? who is talking value that we have assigned to the word young 15 years old. This is a definite value. I have told you the reason for ariasis of vague that belongs to this incomplete. The example what we are seeing does not belong to the incomplete statement, inconsistent statement, but it belongs to imprecise statement. Imprecise means not clear, somewhat vague. We are having somewhat vague in assigning numeric values. For old, past, young. Gunashekar sir? Gunashekar sir? Sir?
I request all to unmute.
Some disturbance.
Yeah,
has
ma'am.
been-
One.
If the temperature is warm and the speed is not very fast, then
Okay,
pressure
ma'am.
is, it's okay, it's okay. Then pressure is slightly decreased. All these definite values are in this successive example is replaced by some adjective and adverbs. You can notice this as adjective and adverbs. If the temperature is warm, it is not very fast, slightly decreased. This is also belongs to the reasoning statement since it involves if and then. It belongs to imprecise statement since we are not having any definite data, some imprecise data, warm, very fast, slightly decreased. So these are handled through mathematical concept. Mathematics means totally it is going to deal with logics and numbers. Since we are not having any numbers involved in it, we don't know how to handle with the arithmetics. So for that we require some numbers. What are the numbers that are going to help us to deal with these type of sentences? That is, I hope that you can understand well. Do you have any doubts still for? As we have seen some example for imprecise, now we are going to deal some uncertainty. Uncertainty means we are not going to have any clear informations. We are always going to deal with the informations, no clear information. In this uncertainty, we are going to deal with two different concepts. One is fuzziness and other one is randomness theory. So we have to first of all understand what type of informations can be dealt through probability and dealt through possibility theory. So we cannot deal these type of uncertainty through possibility. These are the things that we can deal through possibility theories. Linguistic uncertainty, low price. We don't know what do we mean.
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yes, fine, fine. What is this? This is an apple. Is it a green apple or orange, red color apple? What
Maybe
will you?
green.
It is
Green.
green or there will be an uncertain availability of the green apple. Now we can deal with two situations arise. What are the two situations? Chance of getting an apple, guarantee that the bought apple is green. What mathematics?
Ma'am, there is a disturbance. There is a disturbance. There is a disturbance.
If they are not interested, they can. What mathematics can address this
I
guarantee?
request all.
Who is that? Chance of getting an apple. Chance of getting an apple will be dealt through probability. What method is this chance? Chance means only probability. Guarantee that the bought apple is to be green. We can say that how many what can be the membership for this apple to be a green as by perception? Can this uncertainty be addressed through this set theory? No, we can see this later. Look to these questions. When corona be eliminated? When corona be partially or totally eliminated? What is the chance of eliminating corona? Which of the above sentence contains uncertainty? One equates question number 1, 2, or 3. Which question is meaningfully asked? Is the question possess meaningful uncertainty? How can we address uncertainty mathematically? That is very important. As and when we come to understand that there is some uncertainty in this particular information or particular domain or particular background, as a mathematician, we have to think, can we deal this situation with mathematics? In order to deal a particular situation with mathematics, what we require? We require logic and the numeric. And then we can, if it will happen means what can be the probability for occurrence of the particular event. Statistics means it will deal with clear data of an occurred event. It will deal with the cleared data of an occurred event. What do you mean by fussiness? This is very important for us to. These are the words that you can understand. We should compulsorily make use of probability. Now look into these pictures. In order to understand the concept uncertainty, there are two types of logics. One is called as traditional logics. Another one is called as fuzzy logic. You look into the roses given here, 3 roses. It will fall into. It will fall into the category of fuzzy. Look into these pictures. What color is this leopard? Wow, is it clear image? No, it is an uncertain image. Mixture of various colors. Look into the geometrical uncertainty. For based on the essentiality and also intuitive in nature. Based on the essentiality and intuitive in nature, what are the mathematics that are evolved through essentiality? Philosophers can also give some logic. Having any logic and numeric, we should have some capability to arrange logics and the numerics in a particular way to get the output for the background. Philosophers such as Plato, Socrates, Aristotle provide logics to mathematics. Physician Newton and Einstein has also provided mathematics. Engineer Zade and Fourier, some statisticians, and also many others. Intuitive mathematics is contributed by the great Ramanujan and many others. So far, we have seen some situations which involve imprecisions and uncertainties. Real world problems are very complex, very difficult. They are associated with some sort of imprecisions and uncertainties. How can we address this? What is the mathematics that is going to help us? Who invented the mathematics which addresses the uncertainty which cannot be dealt by the principles of probability? That is, we are going to see all those informations now onwards. Mathematics are essential in understanding the whole world. This is a statement given by Pythagoras. You could observe these 3 people. They are nothing but Plato, Socrates, and Aristotle. I already told you that some of the philosophers has given beautiful contribution towards mathematics. Look into these statements. Law of excluded middle. It is given by Plato. What do we mean by law of excluded middle? A union A bar is a universal set. Law of contradiction. A intersection A bar is equal to empty is given by Aristotle. Plato said that there is a world beyond the paper given by Zade who found the world to one which deals with fuzzy mathematics. Prior to the year 1965, people used to believe that, but in the year 1965, L.A. Zade, which is at higher level compared to the classical set. As we all mathematicians, we know that characteristic function is a membership function that is defined through classical set. We cannot address many of the uncertainties. It is not here, but as far as fuzzy set is concerned, he will also be given some numeric value other than 0. That is membership value other than 0 with respect to n. How will you overlap it with the successive years? Look into this fuzzy granulation. We have segregated all our lifetime into 3 categories: young, middle-aged, and old. This young starts from 0 onwards and it prolongs up to some 30. But the age between 25 and 30 will fall into both the categories of young as well as middle age. This is the only benefit that we are having through fuzzy. Even then, the last member in the young will be given some membership in young as well as some membership in middle age. He will be taking the membership of least membership in the middle age and the highest membership in the young. It is essential for us to understanding the membership value in a clear manner. What do we mean by membership value? Value means it is going to take numeric. It will be understood in the concept of numeric. Membership value is nothing but the degree of belongingness. Degree of belongingness, we are going to assign numeric values for the belongingness. As far as crisp set theory is concerned, membership value are only 2. As far as fuzzy set theory is concerned, belongingness will be assigned between the values 0 interval 0, 1. Membership value will be called in this context as characteristic function. Membership value will be called as fuzzy function. How can we define membership value here? Membership value here can be defined as x is equal to 1 if x belongs to A. It is wrongly mentioned. If x belongs to U is the universe of discourse. To every member in the universe of discourse with respect to some attribute, I am going to assign the membership value to every element between the interval 0 to 1. So that is, will never leave anyone. You can understand this. This is the logic, definite logic. This is somewhat confused logic that is called as fuzzy logic. Here you can see mixed up. This is called as warm water. Warm water means if we can mean extreme hot and extreme cold. That is warm water. Warm water will come into the category of fuzzy. With respect to Boolean logic, hot and cold. Hot means 1, cold means 0. Here we have arranged the persons from smaller height to greater height. But we want to be neglected. They also will be given some numeric values. This boy is given the numeric value is 0.6 membership value. This may be 7, this may be 8, this may be 9, and he may be 1. Like that, we are going to give some numeric value between 0 to 1 with respect to the tallness of each and every member in the football team. In numeric values, in fuzzy logic application, how will we call these variables? These variables are non-numeric variables and also they are called as linguistic variables. Linguistic variable means the school is the linguistic variable, fast is the linguistic variable, young is the linguistic variable. A linguistic variable is nothing but a fuzzy variable. Since we are mathematician, we always be interested in dealing with, in working with variables. Here, the background is fuzzy, so it is called as fuzzy variable. For example, the statement John is tall implies that the linguistic variable John, here this is the linguistic variable, and this tall is the linguistic value. This tall is the linguistic value. You will be understanding these things in the successive examples. Linguistic variables are nothing but the noun used to represent phenomena under study in fuzzy sets. Here the noun what I'm using here is John. So John is the linguistic variable here. The system as furnace, school and car. What can be the linguistic variable and what can be the values? To a variable we can assign values. To this variable we can assign values. What are the linguistic variables here with respect to furnace? Temperature. Temperature is the linguistic temperature can take. This temperature can take the values cold, temperature can be cold, temperature can be warm, and temperature can be hot. So these things belongs to the value. If we are very clear in and then numeric values, then total application problem will get over. We call this very cold, very good. Here the word very is called as qualifier. Qualifier means we are adding a value, more values to the linguistic values. Hedges, it will be called as hedges. Some more linguistic variables clear in understanding the linguistic values as well as linguistic variables. All these linguistic values in future will be converted into numeric through fuzzy numbers. All these linguistic values will be converted into numeric. As far as we are not having any numeric on our hand, we cannot deal their arithmetic operations. So all these values, all these verbal values will be converted into numeric values. These verbal values are called as linguistic values in the context of fuzzy logic. So assign, these are the linguistic values. What linguistic variable can be suitable to this variable? Can any one of you tell me? Very low, low, medium, high, very high. These are all linguistic values. Okay. This very low and very high are having hedges. Hedges means we are enhancing those linguistic values with the word very, with the word very low. What can be the suitable linguistic variable? Can any one of you give me? I have given you linguistic values. Can any one of you give me suitable linguistic variable? Light.
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 Yes, ma'am. The light can be low,
it can be medium, it can be height, it can be very height.
Yes, good. Yes, good.
Ma'am,
Thank you. Linguistic value, linguistic hedges in the following. The temperature is high. Can you tell me which belongs to linguistic variable here? The sentence temperature is high.
temperature, ma'am.
Temperature is RAM harnessed. With respect to the Boolean logic, we are going to give the answer either yes or no, or true or false. Is RAM harnessed? With the sense of fuzzy, we are going to answer to this question as extremely honest, very honest, sometimes honest, extremely dishonest. Can you identify what are the linguistic values and what are the hedges here? What is linguistic variable? What is the
Ma'am,
linguistic variable here?
honest here is a
Extremely-
linguistic variable, ma'am.
Honest is the linguistic way.
Extremely.
Honest is the linguistic. As I shown you in the example of tallness, crisp set always be dealing with sharp boundaries, not smooth boundaries. A fuzzy set is a set with a smooth boundary, whereas a crisp set has sharp boundaries. The set of married people. The set of married people will always falls into the category of crisp set. So if we see a person whether he is married or not, yes or no answer only will be suitable to this context. So someone of you is disturbing me, please mute your mic. The set of married people. Married people comes under the category of crisp set, very large. What can be the suitable linguistic way?
Car,
Khan.
car. The car is very small. It's very is small, large. It's very large.
Size of
Good.
shirts, pants, like that.
Good. Pants. Fine, good. Garments.
Garment. Yes.
And its corresponding linguistic values. We are going to assign numeric values only to the linguistic values. We could say linguistic variables and corresponding linguistic values. How can we get numeric value to the linguistic values involved below? If the temperature is cold and oil is cheap, then heating is high. This construction is very important for a mathematician who are working in the application part. This application, if and then, this is nothing but a reasoning. According to the background of your application problem, we have to design the reasoning in a very meaningful way, and then you should be capable of assigning numeric value to every linguistic value involved in your reasoning. Once for all, you set all these things, then your application problem is completely over. If temperature is cold, temperature is the linguistic variable and cold is the linguistic value. Similarly, here oil is the linguistic variable, cheap is the linguistic value, then heating is high. With respect to the temperature, the other logic involved is heating. Heating what? Oil. Heating is high. So you should be capable of assigning numeric values to these linguistic values. We are going to see it later. So this is the important flow how it is going to support by the fuzzy numbers. Numeric membership value lies between 0, 1. How can you set fuzzy numbers that lies between 0, 1? These are the types of fuzzy numbers available. Through these fuzzy numbers, we can assign numeric values to these linguistic values. What are the fuzzy numbers? Types of fuzzy numbers: triangular, trapezoidal, sigmoidal, and one can define by himself, and so on. So these are the fuzzy types of fuzzy numbers that help us to assign numeric values to these linguistic values. Is it clear, participants? Is it clear?
Yes, ma'am.
Yes, ma'am.
Designing fuzzy hereafter how the membership starts to travel. Single valued logic to two valued logic. Single valued logic means A and negation A and A complement. That is single valued logic. Two valued logic means both A and A complement. Three valued logic means 0, 1 by 2 and 1. Multi-valued logic finite. Finite means 0 onwards. Similarly, multi-valued infinite logic. Infinite logic falls into the category of the interval 0, 1. So as I told you earlier, it is essential for you to first of all identify the linguistic variable. and then linguistic values. Those linguistic values should be converted into numeric values. Okay, look into the linguistic variable temperature. It constitutes the linguistic values cold, cool, warm, and hot. These are the term set. Now we are going to represent it by means of fuzzy representation. What is the shape of this representation?
Triangular.
Triangular. So to this linguistic value warm, I am assigning triangular membership value. Each and every value is trapezoidal membership function. So we have assigned cold, warm, hot to trapezoidal membership function also. Suppose we are having a set A is equal to A1, A2, A3 up to AN. A is equal to set of all X such that without this property P, we are not able to concept. As far as fuzzy set theory, we are using the word fuzzy set theory. So it is the extension of crisp set theory, and the operations what we already dealt in the crisp background can also be dealt in operations on classical set theory. What are the operations that we have on classical set theory? Union, intersection, complement. Well, look into the logic behind this union. What is the logic behind this union? What is the logic behind this union? Or
Either or.
what is the logic behind this intersection?
And
And okay, fine. Now you come to the logic R. When I am imposing the condition R, will I be getting maximum concept or will I be getting minimum concept? When R condition is imposed,
Maximum concept.
Okay, keep that in your mind because we are going to make use of this in our later part of our definition. When you are imposing AND condition, will you be getting minimizing concept or maximum concept?
Minimum.
Minimum. Have that with you. Complement means not belongingness. Okay.
1 minus.
Okay, fine. Gradually occurs. So suddenly it won't occur. Okay. 0 to 1. So the number 0 and 1 are belongs to the interval 0, 1. Therefore, crisp set is a subset of fuzzy set. 0, 1 is a subset of the interval 0, 1. Therefore, hard membership is visible. Now, what is the linguistic variable and what is the linguistic value here? Who can drive very well?
Drive is the value. Variable.
Drive is the variable and
Very
well.
well. Very
So the drive very well cannot be dealt through crisp logic. It can be dealt only through fuzzy logic. So only membership functions are given here. Now, how can it is taking the property A? Mu of x is equal to 0 means it is not considering the property A. When it is partially in A means it, membership value lies between 0 to 1. This is one of the important, beautiful understanding with discrete universe. The representation is sigma means not addition. You have to indicate in the separate manner. This integration is not operation integration. This is only coming in the numerator membership value. This 3 is given below and 0.5 is given in the numerator. This is not the operation addition. Instead of comma, author is using the symbol plus. Instead of comma, author is using the symbol plus. Likewise for continuous universe. So these are the universe of discourse. A student may take a course a student may take in this semester. Appropriate courses, whether he has chosen the appropriate courses. Nowadays, when choice-based credit system are coming, general elective, experiential learning, open elective, so many courses are coming. It is not essential for students to study only it's his own course papers. He can study out of interest any extracurricular paper also. By that way, they are giving membership value like this. What are all the members? 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Their membership values are given here. Alternate representation is 1 over 0.1, 3 over 0.3. Instead of comma, I told already, we are going to make use of the operation plus. It is not the addition operation plus. This is a simple plus we are using in the place of comma. What type of?
Excuse me, madam.
Yes.
How we are taking this 3 and 4, just in the earlier slide,
For example, I am showing here
we have
that
taken
only, that is, I told
example before this one, where you said it's not addition, it's comma. How we have taken this 3, 4,
Yes.
all that.
which 3, 0.1, 0.3.
3 upon 8, that's, here. This one, yeah. 0.1 by 1 and 0.3.
This is 1 and 0.1 is the membership value to this member 1. 2 is the member
Okay.
and its membership function value.
3. Okay, I got it. Okay, thank you, madam.
Okay, thank you. What type of inverse of discourse is this? This is discrete. This is discrete. To the member 2, to the member 3, to the member 4, 5, 6, 7, and 8. We are going to represent it as a discrete inverse. Years old. How will you design the membership value means? How will you assign the values in the interval 0 to 1 to this particular old? Old is the linguistic value. What can be its corresponding linguistic variable age? What can be its corresponding linguistic variable age? To the linguistic variable age, old is one of the linguistic value. This is the membership function. This is a membership function. It required, in order to design this membership function, we require more skill sets. So this is a diagram for this particular membership function. So continuous universe. These are all continuous universe. How can you understand the continuous universe? It lies between the values 5 to 17. Mu a squared means we are giving some hedges. We are summing hedges means roughly equal, very close. We are saying this now, that is hedges. This is the height. Height is the linguistic variable. This height can be addressed through crisp and this height can be addressed through fuzzy. But which will be meaningful address? Meaningful address for height is only through fuzzy. Here look, the height 179 is totally neglected. Here the value 179 is given as the membership value 0.78. Where is 0 and where is 0.78? So it is totally meaningless to assign membership value to this variable height through crisp. We have to come to a proper decision which is very meaningful. Assigning membership value in the background of crisp or assigning membership value in the background of fuzzy. That means we have to be very clear in understanding this information. The information is name of the person and height of the person. From the word height, we can clearly understand that it is totally meaningless to assign any number through crisp set. It will be highly meaningful to assign numbers through only fuzzy set. Designing membership function requires more skill. So only most of the people are hesitating to use fuzzy sets. This is a sharp boundary for this 0 and 1. This will take a smooth curve. This will take the smooth curve. So this is the diagrammatic representation of fuzzy membership to the linguistic variable height with respect to the linguistic values. You can understand more clearly here. Short, height, average height, and tall. Those who are in the border of average will also be considered as not tall. Somehow those who are at the border of short. Many logical dealing can be done in this intersection area. This is minimum average and maximum short. This is maximum average and minimum tall. This is a diagrammatic representation. Yes, you answered to me in the previous operations on sets through minimum and maximum concepts. Now let us come here. Mu A union B means this union will deal with the logic R. R means with respect to the numbers, we have to consider the maximum value. R deal we are giving here maximum of membership of the set mu A of x, comma, mu B of x. Inverse of discourse are going to be the same, but we are going to change the property. So the property first one is A and the property second one is B. With respect to the property A, this person will be taking some value, for example, say 0.5. With respect to the another property, the same person can be taking another value. With respect to the interest in music, with respect to the interest in sports. Interest in music, he can have 0.5. Interest in sports, he can have 0.7. Okay, we have to consider which one he is having maximum interest. So only for the operation union, concept max. For the intersection, minimum. I hope that you can understand it well. This means for union,
Yes,
yes.
ma'am.
The same containment can also dealt in the context of fuzzy as we are dealing in the context of crisp background. Similarly, the complement is 1 minus this is a maximum value. Equality also holds good. These are some of the examples. Since our topic is application and time is also passing, let us go to the application part as early as possible. All the properties that are dealt in the background of crisp set theory have to be deal in the context of fuzzy set background. What are the properties that we are having? Involution, commutative, associative, distributive, idempotence, absorption, De Morgan's law. If some property fails, let us see what are those properties. This is the one. Invalid properties in the fuzzy set. Law of contradiction. Who has given law of contradiction? In the beginning of the lecture, I have given 3 people: Aristotle, Plato, and Socrates. So a person has given law of excluded middle and another person has given law of contradiction. These two fails here. What is the meaning for this? Suppose a person is having membership value for a particular property as 0.3. Okay. What can be A complement? 0.3 is the 0.7.
0.7.
When you are taking intersection means minimum of 0.3, so it will never
So you'll
be
get 0.3.
0. It won't be 0. We cannot say never be. Sometimes suppose he is taking 1 for the membership function. What can be the complement? 0.
0.
What can be the intersection value? 0.
0.
At that case only it happens. It is not, we cannot generalize it. Okay, so only this law of contradiction fails here. Same way, law of excluded middle. A is 0.3, A complement is 0.7 means what is its union?
0.7.
0.7. It won't take 1. It will take 1 only in the context of if suppose A is 0 or A complement is 0. So these two laws fails because of this concept. This is not a null set. This is also not an universal set. Apart from these ideas, apart from the ideas that are extended from the classical set theory to fuzzy set theory, this fuzzy set theory itself having its own you are taking every element in the universe of discourse to the another universe. Yes, this is the one. This is the one. We are taking every member in the universe of discourse to the another world which contains the numbers 0 to 1. Can we stay back in this place itself? No. Sometimes it is essential for us to move back to our original domain. Suppose you take the score of students in the mathematics subjects, we will be calling it as 70, 60, 80, 75 and all. Convert it into 0 to 1. Okay. We cannot call the numbers. We cannot call 0.75 come here, 0.23 come here. We are going to call the persons who scored that particular value. For that, we need to travel from transformed domain to the original domain. What is the concept we are calling here? Moving from the transformed domain to the original domain, that is called as through alpha cut. Alpha is the value between 0.5. Sometimes we will be calling the students in order to give first prizes. How will we call those who have secured some particular above particular value? Those who have secured greater than 90, you please come. Greater than 90 means 0.9 is the alpha cut. 0.9 is the alpha cut. We are going to call, we are going to define a cut here that is called as threshold value. Application side or engineers will be called that as a threshold value. That's a top value. From that onwards, we are calling the people. For that reason, it is essential for us to define inverse. This is a type of inverse. That inverse is named here as alpha cut. That inverse is named here as alpha cut. So it is essential to understand extended definition or its own specific definition in this particular area. So alpha cut and the collection of all alpha cut is called as level set. Normalized means at least one member should have the membership value as 1. Support means all the members should have the value greater than 0. Greater than 0 means we will be having some confidence. No one is failed. 0 means we will be considering it as failure. So all the members should secure the value greater than 0. At least one should secure the highest. We are going to consider some values as alpha cut. Collection of alpha cuts are called as level sets, and fuzzy numbers we are going to see in future. Magnitude is nothing but the size. We are going to add upon all the membership values. So you can crossover point means the point which is suitable for both membership and non-membership, that is 0.5. Support of A, the definition is, as I told you now, we are going to collect all the members, those who are securing the value, membership value greater than 0. Those members will be support to us. Height means the highest value in the membership value. Highest value in the membership value. Normal means highest value should be equal to 1. Subnormal means less than 1. So these are some of the examples. Because of scarcity of time, I'm going fast. So alpha cut, I told you know, from the background of from the 0, 1. From the codomain 0, 1, we are going to give it some threshold value. Mu A of x is greater than or equal to alpha. We are not going to collect the alpha. We are going to collect its corresponding x value. Its corresponding x value means traveling back to the original domain, imposing some condition on the codomain 0, 1. For example, senior or consider all the senior, young, junior will be coming under the category of linguistic values. Linguistic values. You collect 0.6 means collect all the seniors who secure the age greater than 0.6. These are the persons. This is called as subsethoods of alpha cut. Subsethood of alpha cut means if our alpha value is larger, then the collection of members of X will be smaller. If the alpha value is membership value is lax, means we can get more members. Some more other definitions are core. Core is nothing but comprising all the elements that contains the value as 1. This is the core. This is the core. This is the support. Support means no member will be having membership value as 0. These are called the boundaries. Boundaries means not considering the core values. The other values other than 1 are called as boundaries. So these members are securing 1. We are going to consider the other members not having the membership value as 1 are called as boundary. Support means no member is going to have the membership value as 0. Non-zero membership. That is called as non-zero membership. Boundary means 0 less than or equal to 1. Lies between membership value lies between 0 to 1. After designing the applications, we have to select all these types from the applications. So only we can have some further analysis. For further analysis, we require all these things. Cardinality means, as I told you, you have to add all the membership values. Relative cardinality means normalization. Normalization means you divide it by total number of members, that is modulus of X. These are the things through examples. Fuzzy logic is all about degree of truthness. Degree of truthness. Probability degree has nothing to reason about the things that are entirely true or false. It is not going to deal with truthness. So as I told you earlier, you should have some knowledge about adjective and adverbs so that you can easily identify what are the adverbs that addresses probability. That address probability are possibly, definitely, certainly, clearly, obviously, perhaps, probably, maybe. These words cannot be dealt through fuzzy logic. How fuzzy logic has taken its growth. Zarde introduced fuzzy set theory in the year 1965. Research groups were from Japan in the 1970s. In 1974, Mamdani, his very important person, his memberships are taken in MATLAB for beautiful applications of fuzzy controls. Mamdani from the United Kingdom developed the fuzzy first logic controller. Du Bois applied fuzzy sets in comprehensive study of traffic conditions. 76 to 87 industrial applications of fuzzy logic in Japan. Japan is the main country which majorly uses fuzzy logic. Presently, it started its boom from the year 1985 onwards. This set is used in digital systems because of the assignment of the membership values from 1 to 0. Fuzzy sets are used in the intelligence systems. Nowadays, artificial intelligence is dominating the whole world. So fuzzy set is highly required in order to deal with the intelligence system. Because of it, assignments of membership values between 0 to 1. Intelligence systems are systems that can exhibit some example. A simple intelligence system in the chat. New computing methods based on fuzzy sets or logics can be used in the development of intelligence systems for decision making in the robot. How to go to the right? Is there any obstacle? How to identify the obstacle like that? Decision making, identification of pattern recognition, optimization, and control. Look here, this is automatic braking system. Close and far. Close, the word close and far should not be dealt through crisp logic. It will meet failure. Look. So as research and development, including engineers, mechanical, civil, chemical, aerospace, agriculture, biomedical, computer, environmental, geological, industrial, mechatronics, mathematicians, computer software developers, researchers, natural scientists, chemistry, earth science and physics, medical researchers, social scientists, economics, management people, political science, psychology, public policy analysts, business analysts, jurists, fuzzy logics. These are the domains. Now we are going to give some specific applications. Facial pattern recognition, air conditioning, washing machines, vacuum cleaners, anti-skid braking system, transmission system, control of subway system, unmanned helicopters, knowledge unmanned, no man. Knowledge-based systems for multi-objective optimization of power system, weather forecasting, weather for models for new product prices and project assessment, medical diagnosis and treatment plans and stock trading. It is also successfully used in numerical fields such as control systems, image processing, power engineering, industrial automation, robotics, consumer electronics. Consumer electronics are nothing but electronic goods such as washing machine, air conditioner, dishwasher, vacuum cleaners. These are all the consumer electronics and some more. This branch of mathematics has instilled new life into scientific fields that have been dormant for a very long time. It was inactive for a very long time. Thousands of researchers are working in fuzzy logic and producing patents and research papers. Look into this word patent. So you can do patents also by the usage of effective usage of fuzzy logic. According to Zarde's report, On the impact of fuzzy logic on March 4, 2013, there are 26 research journals on the theory and applications of fuzzy logic. There are 89,365 publications in applications, and he has given some data. He has also launched an initiative in soft computing laboratory, Berkeley Initiative in Soft Computing Laboratory at University of California to advance this theory and application. The objective of this special issue is to explore the advances of fuzzy logic in large number of real-life applications. You can take the journal from this laboratory, published with this laboratory. Although fuzzy logic has applications in a number of different areas, it is not yet known to people unfamiliar with these intelligent systems. How to apply it to the intelligent systems? They are not familiar with this. How it can be applied in different products that are currently available in the market. For many people, the engineering and the scientific meaning of the word fuzzy is still fuzzy. Still, they are having some confusions. It is important that these people understand where and how fuzzy logic can be used. I hope that I have given some light, or I have thrown some light on you all people, where and how fuzzy logics can be used, how to identify linguistic variables and linguistic values in a particular domain, reasoning, and its corresponding numbers. Are you clear about it? Participants?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Washing machine, microwave
madam.
oven, and fuzzy in collision
Very
avoidance.
good session, ma'am.
Suppose we are having traffic can be avoided. That is very important. Fuzzy set is fully defined by its membership function. So we have learned only the boundary part. The interior part is nothing but the designing membership function. Degree of belongingness. It is essential for a fuzzy number to satisfy all these conditions. A must be a normal fuzzy set. At least one member should take the value 1. Its alpha cut must belong to this interval. The support must be bounded. A fuzzy set is completely characterized with the membership function. It is a subjective measure. It is not a probability measure. It is based on the subject. We are going to measure it. For example, tall in Asia is given like this. Tall in USA, tall in other country. Height and its corresponding membership values. This is the triangular shape membership value. Triangular shape. And at least one member should have the membership value as 1. In the triangular membership value, its speciality is exactly one member will be taking the membership value as 1. How to design it? By a simple equation of line method. This is the structure. This is the structure. 0, B, C, A, and so on. If the value, if the element is having the, if X is less than or equal to A, all the values lie between B to C will be named as X. All the values lies between C to A also will be named as X. We are going to design the membership value in this region to this region, and also we are going to design membership to this region. So only it is segregated in the middle. X minus A. X minus A divided by, sorry, it is not clear. These are the other types of membership function. Triangular trapezoidal means more than one member will be taking the membership value as 1. More than one member, if he is taking membership value as 1, then we can Gaussian. Now come into the designing of membership function. Suppose we are a triangular membership function. A, B, and C means all the values below A will be taking the value as 0. All the values above C will be taking as the value as 0. So the intermediate, this region and this region alone, we are going to assign the membership value in such a way that you take any value in the interval A, B as X. Okay. This is X minus A divided by B minus A. The reason for dividing it by B minus A is to normalize. Similarly here, C minus X divided by C minus B to normalize. So by this way, we are going to assign the membership value, numeric value, if we are considering particular linguistic value as triangular. Particular linguistic value as triangular. That means only one member. Only one member in the domain is going to take the highest value 1. In that situation, we can opt triangular membership value. This picture is clearly stating these are not under our membership consideration. These are also not our consideration. This is the trapezoidal membership value. Trapezoidal value, we have considered only 3 breakups, A, B, and C. Here we are going to consider 4 breakups, A, B, C, D. So between this B and C, members are going to take the value as 1. Therefore, there are more number of trapezoidal membership value and the designing is almost the same. Take a value x, A less than or equal to x less than or equal to B means x minus A. X minus A divided by B minus A. Similarly, in this case, x minus D divided by D minus C. And throughout this B and C, in the interval, everyone are going to take the value as 1. This is the membership value for Gaussian membership value. So when the cause of this, the machine will get good experience and memorizing the programs and to minimizing the running cost. For minimizing the running cost, this fuzzy logic is applied in Gaussian machine because of this involvement of fuzzy linguistic values. Fuzzy types of that. That is the linguistic variable. That the type of cloth is the linguistic variable. Mass of cloth is the linguistic variable. Temperature is the linguistic variable. So all types of detergent means chemical engineer is required. Stain, the chemical property will be given to the stain and washing in water. The information regarding the upper and lower threshold of temperature, the fabric, cloths, detergent and stain required. Other factors can also be included. By this way, you can very dry, normal bed. These are the concepts for humidity. Similarly, these are the linguistic values, minimum value or maximum value as your requirement. The other household appliances, air conditioner. Here also you can use. Other fuzzy logic applications are defense, electronics,
And semantic rule, ma'am.
syntactic rule and semantic. Syntactic rule and semantic rule. Yes, Gunashekar sir. Gunashekar sir.
Yes, madam. Can we conclude, madam?
Shall we stop?
Yeah, wait, madam. Our colleague will conclude.
Cosmetic design material.
Scholars are now doing for fuzzy differential equation. They are very much knowing
Yeah,
about the
yeah,
basics, madam. Now they are
Yes,
impressed. They impressed a lot
My
our lecture,
motive
madam.
is to give the important basics. If one understands very well on the basics of every subject, then he can do wonderful research. He must know, he or she must know what is the reason for this particular. They would have listened.
Give a command. Our colleague will give a command.
Hello, ma'am. Good afternoon, ma'am.
Yes, good afternoon.
Very useful for me, ma'am, because I'm also doing research in this theory, ma'am.